This is a lesson for Algebra 1-1. The learning target for today is I can determine the independent and dependent variables in different scenarios and match the graph with a scenario. So when we're looking at graphs and things like that, there are two quantities that are changing in each situation. When one quantity depends on the other in a problem situation, it is known as the dependent quantity. The quantity that the dependent quantity depends upon is called the independent quantity. One of the ways that you can really think about this is with this saying here at the bottom: the dependent depends on the independent. The dependent depends on the independent. You'll see me quite often write D, D, I. The dependent depends on the independent. So independent is almost always time. Now, time can be in a lot of various different ways. You could have the standard hours or minutes or years, but then you could also have things like weeks or the number of games or things like that as well. Anything that deals with time. And that's probably 99% of the time. The dependent is the thing that is changing. So we're going to see these in a lot of different ways and a lot of different scenarios in this lesson. So what they want you to do here, they give you 4 different scenarios, and they want you to identify the independent and the dependent in each scenario. So the number of hours worked and the money saved. Remember that the dependent depends on the independent. And remember, the independent is always your time. So the number of hours worked and the money saved. The number of hours is your independent, and then the money earned is your dependent, because the amount of money earned depends on how many hours you work. The more hours you work, the more money you earn. Your grade on a test and the number of hours you studied. Now, most of the time this is true. Sometimes it's not, but most of the time this is true. So the number of hours you studied is the independent, and your grade is the dependent, because the more you study for a test, more likely the higher your grade is going to be. The less hours you study for a test, the lower your grade will be. The number of games played and the number of points scored. So on this one, the number of games played is your independent, because that's your unit of time, and the number of points scored. Now, most of the time, the more games that you play, the more points you're going to score. So the number of points depends on the number of games played. The speed of a car and how fast the driver pushes down on the gas pedal. Now, this one doesn't have a unit of time, but the dependent, the speed of the car, depends on how far you push down the gas pedal. If you push down the gas pedal farther, you're going to go faster. If you push down the gas pedal less, you're going to go slower. So the speed of the car is the thing that is changing. So that is the dependent. When we go to graph these, the independent is always on the x-axis. That's always on the bottom. So your time is always on the bottom. That's one thing that you need to remember. The time is always on the bottom. Again, whether that's weeks or months or years or hours or whatever it happens to be. Along the side is the thing that is changing on your y-axis. Easy way to remember the x-axis and the y-axis. Y-axis starts with the letter Y. Nod your head yes. The word yes starts with Y. That goes up and down, just like the y-axis goes up and down. So now we're going to look at some different graphs, and we have to match the graph to the scenario. So this first one says something's fishy. Candace is a building manager for an office building. One of her responsibilities is cleaning the office building's 200-gallon aquarium. For cleaning, she must remove the fish from the aquarium and drain the water. The water drains at a constant rate of 10 gallons per minute. So remember, independent is your unit of time, which in this case is minutes, because the water is draining at a constant rate of 10 gallons per minute. The dependent quantity is the total amount of water. That's the thing that's changing. As time goes by, the water level is dropping. So the graph that matches this scenario would be this one, because it is going down at a constant rate. It is a straight line going down. That means it's going down at a constant rate. If it was a variable rate, you would see more of a curvy line. Smartphone, but is it a smart deal? You've had your eye on an upgraded smartphone, however, you currently do not have the money to purchase it. Your cousin will provide the funding as long as you pay him interest. He tells you that you only need $1 in interest initially, and then the interest will double each week after that. You consider his offer and wonder, is this really a good deal? So you're paying interest, you're paying $1 the first week, and then it's doubling each week. So after week 1, you're paying $1 in interest. Week 2, you're paying $2, and now it's going to double each week. So week 3, you're paying $4 in interest. Week 4, you're paying $8 in interest. Week 5, you're paying $16 in interest. Week 6, you're paying $32 in interest. So the independent, remember, is always time. In this case, it happens to be weeks. The dependent is the amount of money being paid. It's the interest. So the graph that matches it would be letter B, because this is going to quickly spike and go up as time goes by. So as time goes by, the amount of interest being paid is getting higher and higher and higher and higher. It wouldn't be a straight line, because that would mean it is the same amount of money being added each week, like $2 each week. Well, it's not, because we have $2, then it's increasing by $4, then it's increasing by $8, then it's increasing by 16. So that's why we have this curved line. Can't wait to hit the slopes. Andrew loves skiing. He just hates that the ski lift ride back up the top of the hill. For some reason, the ski lift has been acting up today. His last trip started fine. The ski lift traveled up the mountain at a steady rate. Steady is constant. So we're probably looking for a straight line at about 83 feet per minute. Then all of a sudden it stopped, and Andrew sat there waiting for 10 minutes. Finally, the ski lift began to ascend. Ascend means to go up the mountaintop. So the independent is always your time. So in this case, we're talking about minutes. The dependent is the feet above the ground, because the ski lift is gradually going up and up and up and up and up. So the one that matches this is choice G, because the ski lift goes up, 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 and then it stays still for about 10 minutes. It's not going up, but time keeps on going by. And then it starts going up again. So that would be graph G. It's magic. The amazing Aloysius is practicing one of his tricks. As part of his trick, he cuts the rope into many pieces and then magically puts the rope back together. He begins the trick with a 20-foot piece of rope, cuts it in half. He then takes one of the halves and cuts that piece in half. He repeats this process until he's left with a piece so small he can no longer cut it. He wants to know how many total cuts he can make and the length remaining of each remaining piece of rope after the total number of cuts. So the independent quantity, this one is a little bit weird because it doesn't really have time, but the independent quantity is your number of cuts. What's changing after each cut is the length of the piece of rope. Because if he's starting off with a 20 feet length of rope, he makes one cut in the middle. So now he has a 10 and a 10. If he cuts those in half, then he has a 5, a 5, a 5, and a 5. If he cuts those 5s in half, then he ends up with 2.5s, and he has 8 of those. He would do it again, he would have 1.25, and he would have 16 of those. So what's happening each time is, as time goes on, the number of cuts is increasing, all right? So the number of cuts is going over to the right, and the length of each piece of rope is decreasing because it's getting smaller and smaller and smaller. So that would be graph D. Baton twirling. Jill is a drum major for the Altadena High School marching band. She has been practicing for the band's halftime performance. For the finale, Jill tosses her baton in the air so that it reaches a maximum height of 22 feet. This gives her 2 seconds to twirl around twice and catch the baton when it comes back down. So again, we are talking about time. So the independent quantity would be the time the baton is in the air, because she's tossing it up in the air. The dependent quantity is the height of the baton. So if you think about it for a second, she's throwing it up in the air and turning. So the height of the baton, she is starting right here. Notice it's not starting down on the ground because she's not throwing it from the ground. She's throwing it from like her hand. So it's going up in the air and then coming back down as time goes by. And then she catches at the same place where she released it. So that would be graph F. Music club. Jermaine loves music. He can lip sync almost any song at a moment's notice. He joins Songs When I Want Them, an online music store. By becoming a member, Jermaine can purchase just about any song he wants. Jermaine pays $1 per song. So this one's a little bit weird as well. The independent quantity, it's not time, but it's the number of songs purchased, just like it was the number of cuts in the rope one. So the number of songs purchased is the independent. What is changing is the cost, because the dependent depends on the independent. The total cost depends on the number of songs purchased. So the graph that matches this one, he's paying $1 per song. So he buys one song, and it's $1. Two songs, $2. Three songs, $3. Four songs, $4. And it keeps on going up at a constant rate. A trip to school. On Monday morning, Myra began her 1.3-mile walk to school. After a few minutes of walking, she walked right into a spider web, and Myra hates spiders. She began running until she ran into her friend Tanisha. She stopped and told Tanisha of her adventurous morning and the icky spider web. Then they walked the rest of the way to school. So she's walking to school. So time, all right, in minutes. I know it's minutes because it says minutes in the problem. The dependent quantity is the total distance that she's walking, because as time goes by, the distance keeps on increasing. So she's walking. She ran, all right, she began running. So that's going to go at a steeper slope, all right, a steeper pitch to the line. Then she stopped for a little while. So her distance is not changing, but time keeps on going on. And then she's walking again. The Jelly Bean Challenge. Mr. Wright judges the annual Jelly Bean Challenge at the summer fair. Each year, he encourages the citizens in his town to guess the number of jelly beans in a jar. He keeps a record of everyone's guesses and the number of jelly beans that each person was off by. So again, there's no time in this one, but it's the number guessed, just like the number of cuts, and in the previous one, the number of songs purchased. So the dependent is how much it is off by. So this one's a little bit weird. So if you're too low, as the number guessed, it's going to get closer and closer and closer to the correct answer. And so that's going down, because if you're too low, if you're 5 off and then 4 off and then 3 off, you're getting closer and closer to the number guessed. And then it's getting higher and higher and higher as you get farther away from the correct answer. That one's a hard one. Now that you have matched the graph with the appropriate situation, let's go back and examine all the graphs. What do you notice about all the graphs? Well, what you should be noticing is that all of the graphs are continuous. They are all a continuous line, meaning that they're not segmented, meaning that they're not like dotted and things like that. They're all one continuous thing, whether they're going up or down or curved or whatever. They're all one continuous thing. What are some differences that you notice? Well, some graphs went up, some graphs went down, some graphs did both. How did you label the independent and dependent? All right, the independent is always at the bottom. The dependent is always at the side. Remember, your time is always at the bottom. Analyze each graph from left to right. Describe any graphical characteristics you may notice. So when we go from left to right, sometimes you're going to increase, sometimes you're going to decrease, sometimes it's linear, which means it's forming a straight line, and other times it is curved. Compare the graphs for each scenario and describe any similarities or differences that you notice. So if we take a look at the smartphone, which is the B graph, and the music club. So B and A. Let's take a look at B and A. So if we take a look at B and A, which are these two, notice that A is linear, all right? It is a straight line, where B is curved. That's one difference. How they're similar is that they're both increasing. As we read a graph, we go from left to right, just like we read a sentence. So this is going up and this is going up. So comparing H and D. All right, let's compare H and D. So D and H, these two on the end, they are similar because they're both going down. They're both decreasing as we go from left to right, just like we read a sentence. Differences would be this one is curved, D is curved, and H is straight or linear. And the last one, F and C. F and C. Let's take a look at F and C. So with F and C, they're both going both up and down. So they're both increasing and decreasing. One of the differences is this one is curved. F is curved, where C is linear. Another big difference is that F goes up and then down. So it increases and then decreases, where C decreases and then increases. Again, the biggest thing that you need to remember is that the dependent depends on the independent. Your independent is always your time. Your dependent is the thing that is changing.